Hello, in this lecture I will give you a proof to the Pythagorean theorem. The Pythagorean theorem relates to a right triangle, and it actually says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or in mathematical notation we can say that c squared is equal to a squared plus b squared. So in order to prove the Pythagorean theorem, we actually built a copy of this right angled triangle. A copy of this triangle is here, and actually we built it by building the side A along the side B, and then we actually raised a perpendicular to side A, so the angle between side A and side B in the left triangle is equal to 90 degrees. So now we have two triangles that coincides to each other, and I will explain you why. Because we have two sides that are equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle. And also the angle between side A and side B is equal to 90 degrees, and so is in the this is in the right triangle, and is the same with the left triangle. The side A, the angle between side A and side B is 90 degrees, because side B is perpendicular to side A. So we have two sides that equal in those two triangles, and also the angle between these two sides is equal in both triangles, and it is actually 90 degrees. For this reason, the right triangle coincides to the left triangle. So if we label the angle between side A and side C in the right triangle as alpha, then the angle between side A and side C in the left triangle must be also alpha. And actually the angle between side B and side C in the right triangle will be labeled as x, because we don't know how much degrees is the angle between side B and side C in the right triangle. Okay, so we know that in every triangle the sum of its angles equals to 120 degrees. So we can write that alpha plus, here is 90 degrees, the angle between side A and side B in the right triangle is 90 degrees, plus the angle between side B and side C in the right triangle is x. We don't know what angle it is, so total the sum of the three angles equals to 180 degrees. So you can see it here, alpha plus 90 degrees plus x, so the sum of the three angles in the right triangle is equals to 180 degrees. Here we can subtract 90 from both sides of the equation, and then we will get that alpha plus x is equal to 90 degrees. As you can see here, we subtracted 90 degrees from both sides of the equation. Now we will deduct x from both sides of the we will deduct alpha from both sides of the equation, and we will get that x is equals to 90 degrees minus alpha. So we deducted alpha from both sides of the equation, so we got that x is equal to 90 degrees minus alpha. So we can write here that x is equals to 90 degrees minus alpha. Okay. Now we can label the angle between side A and the side C in the right triangle to side C in the left triangle. We can label the angle between them as y, because we don't know how many degrees the angle is, but we know that in every straight line, like BA for example, the sum of the angles from one side of the line, this is one side and this is the other side, in every side the sum of the angles is equals to 180 degrees. If you see the bottom side is 180 degrees. But also the upper side of line BA is also equals, the sum of the angles equals to 180 degrees. So x plus y plus alpha equals to 180 degrees. So we can write that x plus y plus alpha equals to 180 degrees. That is a very simple rule that in every line, every straight line, you have two sides, and of course the total angles, the sum of the total angles in every straight line is 380 degrees, and the sum of the angles in one side of the straight line is 180 degrees. So x plus y plus alpha equals 180 degrees. Okay, now we know that x equals to 90 minus alpha, so we'll substitute the variable x with 90 minus alpha. So we got that here we substituted x with 90 minus alpha. So we got that minus alpha plus alpha is 0. So we can write that 90 plus the angle y equals to 180 degrees. Okay, we eliminated the variable alpha because minus alpha plus alpha is 0. Now 90 plus y equals 180 degrees. We will substitute 90 degrees from both sides of the equation. Then we'll get that y equals to 90 degrees. So the middle triangle is right angled triangle because the angle y is equals to 90 degrees. As you can see here, we substituted 90 from both sides of the equation. So we got that y is equals to 90 degrees, or y is a right angle. So we can write here now we have here a trapeze. This is a trapeze. We can calculate the area of the trapeze in two ways, and then we can compare the result of the first way to the second way. We know, of course, that the results are the same because it's the same trapeze, and from that comparison we will get the proof to the Pythagorean theorem. Okay, so we'll start to calculate the area of this trapeze. In the first way, we will name the area as S. So S is equals to the sum of the parallel sides. A is parallel to B, so it is actually A plus B times the height of the trapeze, that is also A plus B, divided by 2. So actually this is the first way that we can get the area of the trapeze, that is actually the sum of the side A plus side B times the height of the trapeze, that is also A plus B. You see that the height is A plus B. All we divide by 2. So this is the first way to calculate the area of this trapeze. Now we will calculate the area of the trapeze in the second way. So we write that S equals to, how we can calculate the area of the trapeze in a different way. We can say that the area of this trapeze equals to the sum of the areas of these three triangles, because the area of the trapeze equals to the area of its components, and this trapeze contains three triangles, so we will actually calculate the area of those three triangles, and in this way we will get the area of this trapeze. So the area of the first triangle is the base of the triangle, that is B, times the height of the triangle, that is A, so it is B times A divided by 2. This is the area of the right triangle. Now the area of the middle triangle also equals to the base of the triangle times the height to this base divided by 2. So it is C times C divided by 2. And the left triangle, the area of the left triangle will be the base A times the height to this base, that is B, divided by 2. So it is A times B divided by 2. So in total we got that the area of the trapeze, when we calculated it in the second way, equals to P times A divided by 2. This is the area of the right triangle, plus C times C divided by 2. This is the area of the middle triangle, and A times B divided by 2 is the area of the left triangle. So we also know that the expression 1 is equals to expression 2. So we will compare these two expressions to each other. We can say that A plus B times A plus B divided by 2, the first expression, is equals to the second expression, that is actually A times B divided by 2 plus C squared divided by 2 plus BA divided by 2. Okay, So in this equation we actually say that the first expression is equals to the second expression, and this is the area of the trapeze when we calculated it in the first way, and this is the other side of the equation is the area of the same trapeze when we calculated it in the second way, by telling that is actually the sum of the areas of the three triangles. Okay, now we will multiply the two sides of the equation by 2. So we multiplied the two sides of the equation by 2, and we got that a times b plus c squared plus ba equals to a times b times a times b. Now we know that AB plus BA is equals to 2AB. Okay, BA plus AB is 2AB plus C squared equals to AB times AB. Now we will open the brackets in the left side of the equation. A times A is A squared plus A times B is AB plus B times A is BA plus B times B is B squared equals to 2AB plus C squared. So here you can see that we actually opened the brackets, so A times C is A squared plus A times B is AB and B times A is BA and B times B is B squared is equals to 2AB plus C squared. Now AB plus BA is 2AB here AB plus BA is 2AB. Now we can deduct 2AB from two sides of the equation. So after we deduct 2ab from two sides of the equation, we got that a squared plus b squared is equals to c squared, and that is what we wanted to prove. That's the square, c squared is equals to a squared plus b squared, and actually the hypotenuse, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. Okay? So actually we can summarize and say that we proved the Pythagorean theorem by actually building a copy of the right-angled triangle. The copy of this right-angled triangle is built here, and we found the angles here, and then we calculated the area of the trapeze in two ways, and at the end we got the expression that we wanted. It is the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so this is the proof of Pythagorean theorem. Okay, thank you very much.